Assalamualaikum and hi. Okay, in this video, you should be able to solve the real problems through the mathematical modeling, which involve the following functions. As you know, in KSSM, we have three types of function, that is linear, quadratic, and exponential, and also communicate the mathematical modeling process implemented. So, are you ready? Okay, let's start. Okay, first of all, how does we determine the types of functions that might be used in our model? Okay, macam mana kita nak menentukan jenis fungsi yang mungkin digunakan dalam our model matematik? Okay, here there's a few graph. Okay, so from this graph, we can see a pattern. Okay, so how to determine the type of functions is by studying the graph patterns. Okay, is by studying the graph patterns that we get, okay, from the data that we collect. Okay, means sewaktu proses kita cuba untuk menyelesaikan masalah tu, we're going to collect the data. Okay, so from the data, we'll do a graph. Okay, so from that graph patterns, we will know what type of function that can be used. Okay, so for KSSM, again, we're going to learn three types of function, that is linear, quadratic, and exponential. So how does it look like? Linear will be a straight line, while quadratic will be a curved graph, which will form the parabola. Okay, it will be like this, or it will be smile. Okay, it will be smile. And the last one is the exponential. It's also a curved graph, but it will increase or decrease in values of data at a sharp rate. So it's a little bit different with the quadratic. Okay, so this is the exponential, this is quadratic. Okay, let us see the first example. I'm going to use the highlighter so that will be easier for us. Okay, here. Hakim traveled 550 kilometers on 50 liters of petrol in his car. If Hakim wished to go to a place which is 264 kilometers away by car, how much petrol in liters does he need? Solve this problem through mathematical modeling. Okay, so if it's only involve solving problem question, you just need to find the straightforward the answer. But for mathematical modeling, there is 6 key components that need to be look. Okay, so the first one is identifying and defining the problem. So in this problem, we have to determine the volume of petrol required for 264 kilometers. So this is our problem. Okay, and then we know that the farther we travel, okay, the more petrol we require. Okay, so memang betul lah, kalau makin jauh mestilah makin banyak petrol yang kita perlukan. So actually here, the amount of petrol varies directly with the distance we travel. Okay, so still remember, varies directly. Okay, you learn this in the first chapter of Form 5 variation. Okay, varies directly means kalau satu variables tu meningkat, satu lagi variable pun meningkat juga. Okay, so samalah ni, makin jauh kita travel, makin banyaklah petrol yang kita perlukan. Okay, second one, you have to make assumptions and identify the variables. Okay, so you have to assume that the speed of driving for both 264 kilometer and 550 kilometer routes are the same. Okay, so kena make sure, kena assume macam tu lah. Kalau tak nanti dia macam tak dapat. Okay, and then we're going to let X represents the distance travel and Y represents the amount of petrol required. And as we have known, this is a varies directly. Okay, so means that Y varies directly with X. Okay, so that you're going to use this formula. Y equals to Kx, where K is the constant. Okay, so remember this is from the first chapter, that is variation. Y equals to Kx means you have to find the K first. Okay then, after you know the formula that you're going to use, you're going to apply the mathematics to solve problems. Okay, here you're going to substitute Y equals to 50 and X equals to 550 into this Y equals to Kx. So it'll be like this. Okay, Y 50, X 550, then K will be equals to 50 divided by 550. So K you will get is 1 over 11. Means the equation here is Y equals to 1 over 11 X. Okay. So now when X equals to 264, okay, because that is needed, that is what needed for this question, you're going to replace the value of X as 264 in the equation here that you got. Okay, so then you will get Y equals to 24 liters. Okay, wait. So this is the applying mathematics to solve problems. So the next step is verifying and interpreting solutions in the context of the problem. As you can see, this is straight line. Okay, this is a straight line because it is Y equals to Kx only. It looks like Y equals to Mx plus C. Okay, so here you have to verify and interpreting solutions, right? But in this verifying, you cannot use the linear function model in all the situations. Okay, you cannot use the linear function model in all the situation. Why? Because if let's say that the 550 kilometer route, you're going through the town and cities, while 264 kilometer route, you're going through the highway. Okay, the car will use up petrol at a faster rate in the first route compared to the second route. Okay, bila kita guna kereta dekat bandar, okay, petrol akan lebih cepat habis. Okay, berbanding highway. Sebab kat sini kan kita banyak, kelajuan kita akan berbanyak-banyak kali ada stop semua-semua tu, so dia akan lebih makan minyak, macam tu. So this linear function model, okay, is not suitable to solve this problem. Okay, so means that you need to do the next step, that is refining the mathematical model. But for this question, we are not able due to limited information given. Okay, so you can write down the report, okay, regarding what you have from the step that you have done, okay, based on the interpretation of solution previously. That's all done. Okay. For example 2, okay, here we have a diagram shows the cross section of a river. A hydrologist measures the depth of the river Y meter a different distance, that is x meter, from the river bank. Daripada tebing sungai. Okay, the results obtained are given in the following table. Okay, we already have the data. What we'll see here, okay, if the distance from the riverbank is 0, the depth also 0. Okay, so means jarak daripada riverbank ni kosong, maksudnya kat sini lah. Okay, so kedalaman dia pun kosong lah. Okay, cetek, it is shallow. Okay, then when the distance is 4, it's more further. Okay, the depth of the river is 1.5. Okay, it's become deeper. When it is 8, the depth of the river also 2.3. It's become deeper. 12, 2.9. 18, 2.9 also. 25, 1.7. Before, it's become more deeper. But then, it's become shallower. Okay, so here the distance from the river bank is 30. It become back 0. So means it might be here. Okay, so now from this data, how we going to determine the depth of the river through the mathematical modeling? So as usual, we need the 6 components of mathematical modeling. The first one is identifying and defining the problem. So our problem now is how to determine the depth of the river. Okay. Second one, you have to make assumptions and identifying the variables. Okay. You may assume the deepest part in the river is the middle with depth decreasing to 0 at the edges. Means kedalaman dia makin berkurang, makin cetek, okay, bila menghampiri tebing. Yelah, kalau sungai kan, kalau kat tebing tu selalunya dia lebih cetek. Okay, and then the two variables involved is the depth of river, that is 1 meter, and the distance from the river bank, we can assume that is as x meter. Okay, you have the data, and then you will apply the mathematics to solve your problems. Okay, by a graph. Okay, by using a graph. Okay, plotting a graph. These data seem to rise and fall in a manner which is similar to a quadratic function. Okay, see? This is the okay, then to present the actual situation in mathematical modeling, we'll use the approximate value. Okay, to present the actual situation in mathematical modeling, we'll use the approximate value. Means kita akan anggarkan sajalah. Okay, so for example, the depth of river is 3 meter when the distance from the river bank is 15 meter approximately. Okay, so here approximately the 15 meter, okay, the distance from the river bank, and then the depth of the river, it might be 3 meters. Okay, so this is what you got from the data. And now, from this data, it looks like a quadratic function. So that is why, in verifying and interpreting solutions in the context of the problem, you may use the y equals to ax squared plus bx plus c. So this is the general form for quadratic function. Okay, so this is a general form for quadratic function. Then I will use any three of the data. So here I'll use 0, 0, 25, 1.7 and 30, 0. This is the coordinate. Okay, this substitute in the equation. Okay, I repeat here. This one means the value of x is 0. The value of y also 0. The value of x is 25. The value of y is 1.7. the value of x equals to 30, the value of y is 0. Okay, why I'm using this? Because I want to get the mathematical model. Means I want to have a formula that can be used, okay, to assume to get another data. Maybe from the data yang tadi, we don't have 15 meters from the riverbank, so um, we might anggarkan, okay, kita boleh anggarkan apakah dia punya jarak tu, apakah kedalaman dia. Okay, so itu tujuan dia. So here from the first one 0 0, okay, I'll put the 0 for y and x also 0, so means finally here I will get c actually equals to 0. And the second one, the y is 1.7 and x equals to 25. Okay, this is from this, yeah, this 25 and 1.7, and then you will get a 1.7 equals to 625a plus 25b plus c. Okay, and the last one, y equals to 0 here and x equals to 30 here, the value of x here, and then finally I will get 0 equals to 900a plus 30b plus c. Right, from the first equation, c equals to 0. Okay, c equals to 0, so here I can substitute the value of 0 here, c equals to 0. Clear? Okay, and then maybe there's one of you might ask why we must substitute c equals to 0 because this is one equation. Okay, so any values here, okay, any values here you can use the same formula kalau betul. Okay, so that's why kalau dekat sini kata c equals to 0, that's why kita boleh masukkan c dekat sini pun as 0 juga. Okay, and then you will get simultaneous linear equation. Okay, this one I don't want to really explain about it because this is you already learned this form 1. Okay, form 1 topics, the linear equation, okay, in the topic of linear equation by using elimination or substitute. Okay, then after you got the, this one is by using the substitution, then you will get a equals to negative 0.0136 and b, after you got the value of a, means you can substitute the value of a into any equation here, then you will get b. So what to do to this value a and b? Just substitute it back to the general form of quadratic function. Okay, here we have a and b and also c. Don't forget c because c is 0. And then here you will get this y equals to negative 0.01368x squared. Again, y equals to negative 0.0136x squared plus 0.408x. Okay, so here after the fourth components, fifth, how to refining the mathematical model. Okay, so as for this model, we assume that the deepest is at the middle of the river, but it might be different in another river. So a new model will be needed if we have a new assumptions. And then the answer also will be more accurate if more data have been collected. Okay, so from the fifth components, that is refining the mathematical model. Okay, you can do the reporting, the findings. You can write down the full report about the modeling framework structure. It might be like this. Okay, based on the data obtained by the hydrologists, okay, seems that the depth of the river at a different distance from the river bank rise and fall just like a quadratic function. Therefore, the general quadratic function has been used to get the possible quadratic function for this depth of the river. So, by using the system of two linear equations in two variables, okay, the possible quadratic function is, you already got this, y equals to negative 0.0136 x squared plus 0.48408x. Okay, and then how to know whether it may be accurate or not? We're going to substitute in for any other value of x. Okay, after being substituted with another value of x, the value of y that we got is approximately equal with the value in the graph. Okay, so but it might be true, for this river only. Okay, it might be not true for another river. So because in this mathematical model, okay, we assume that the deepest is at the middle of the river. So that might be your reporting. You can add up any other things that you think it's needed. Okay, I think that's all for the example 2. So see you in the next video for the next example. Bye!